Hello students, I am Azizi, Professor Electronics, and we are learning the course of Assembly Language Programming using MCS 51 family. In our previous session, we have learned that how to increment the value of the counter with a delay of 1 second using the timer 0 interrupt. In this session, we will learn that how to integrate 3 switches with our program. First, we'll go through our previous program, and then we'll write a new program to integrate 3 switches with our program. So let's start our today's session. And here we can find we have developed a program to increment the counter with a delay of 1 second using timer 0 interrupt. And here we can find the interrupt delay of 10 millisecond. And in this program, we will integrate 3 switches, that is switch 1, switch 2 and switch 3 with our program. And we will use the switch 1 to start the counter, we will use switch 2 to stop the counter, and we will use the switch 3 to reset the counter. So let's see how we can modify our program to integrate these 3 switches, that is switch 1, switch 2 and switch 3. And here we have our previously written program, and in this program we are using an interrupt of timer 0, and here we can find we have written that originate 000BH, which is the interrupt vector for timer 0, and here we have written that ljump timer 0 interrupt service routine, and here we have initialized the value of the timer 0, that is timer low 0 and timer high 0 for the delay of 10 millisecond, and we have also initialized the T mode register for the timer 0 as 16-bit timer mode. And we have moved the value, that is 82H, in interrupt enable register, that is the global interrupt enable and timer 0 interrupt enable. And here we have cleared the bit, that is timer 0 overflow flag, and here we have set the bit, that is TR0, to start the timer. And here we have written the timer 0 interrupt service routine, that is T0 ISR, and we have already discussed the working of this interrupt service routine in our previous session. And now we'll modify this program to integrate 3 switches with our program. And here we can check we have connected 3 switches, that is switch 1, switch 2 and switch 3 on port 2.0, port 2.1 and port 2.2. Now we will assign the name to these 3 switches, that is switch 1 will be used to start the counter, switch 2 will be used to stop the counter, and switch 3 will be used to reset the counter. And here in bits assignments, we'll assign the name to all these 3 switches. So here we will write that is a start switch, and we will write that is bit port 2.0, and we will write stop switch, bit port 2.1, and we will write reset switch, bit port 2.2. As we are using 3 switches in our program, so we will define 3 debouncing register in variable assignments. So here we will write that is db underscore reg1 equ 3ah, and we will define that is db underscore reg2 equ 3bh and db underscore reg3 equ 3ch. In this program we will also write the flag assignments. So here we will write that is, and here we will define 3 flags for 3 switches. So we will write that is strflg, that is bit 00h, and here we can find in bit addressable RAM locations starting from 20h. We have used a bit in our program at the address that 00h, and now we will use the address that is 01 for the next flag, and we will also use the address that is 02 for the third flag. And here we will define the next flag, that is stop flag, that is STP flag, bit 01h, and RST flag, bit 02h. And now we'll initialize our newly defined variables in initialization routine, and here we will write that is move db reg1 comma hash 00h, and we will move db underscore reg2 comma hash 00h, and we will write that is move db underscore reg3 comma hash 00h, and here we will clear the status of our newly defined flags. So here we will write that is clear strflg, and we will write that is clear stpflg, that is stop flag, and we will write that is clear rstflg, and here we will define another flag, that is start stop flag. So here we will write that is ss underscore flg, that is bit 03h, and here in initialization routine we will clear the status of start stop flag. So we will write that is clear ss underscore flg, and now we will use these variables in our program, and now we will add another subroutine in our main program, that is switch routine. So here we will write that is call sw underscore r, that is switch routine, and here before timer 0 interrupt service routine we will write the new subroutine, that is switch routine. So here we will write, and here we will write the name of our switch routine, that is sw underscore r using colon, and here we will check the status of the start switch, and we will write that is jump not bit, that is start switch, control C and control V, that is jump not bit start switch debouncing delay routine 1. So here we will write that is dbd underscore r1, that is debouncing delay routine 1, but if the status of the start switch will be 1, then our program will come to the next line, and here we will write, here we have defined 3 registers for debouncing delay. So we'll use the first debouncing register for the start switch. So we'll copy this variable from here, control C, and here we will write that is move debouncing delay register 1 comma hash 00h, and after executing this instruction our program will get returned from this subroutine. So we will write that is jump sw underscore r underscore ext, but if the status of the start switch will be 0, then our program will jump to the subroutine, that is dbd underscore r1, and here we will write the subroutine, that is debouncing delay routine 1. So we will write that is dbd underscore r1 using colon, and here we will write that is decrement jump not 0 dbreg1 comma, that is decrement jump not 0 debouncing register 1 switch routine exit. So here we will write that is sw underscore r underscore ext, and here on this line the instruction, that is decrement jump not 0, will first decrement the dbreg1 and will compare the value of dbreg1 with 00h, and if the value of dbreg1 will not be equals to 00, then our program will get exit from the switch routine. But if the value of the dbreg1 will be equals to 00h, then our program will come to the next line, and here we will write that is set bit ss underscore flg start stop flag, and after setting the status of ss flag our program will get returned from the subroutine. So here we will write that is jump sw underscore r underscore ext. As we have set the status of ss flag in the routine, that is debouncing delay routine 1, now we'll use this flag, that is start stop flag, to interlock the start switch, and if the status of start stop flag will be 1, then our program will not check the status of start switch, but it will check the status of stop switch. So here we will write that is jump not bit SS underscore FLG comma CHK underscore START start switch, that is jump not bit start stop flag check start switch. It means that if the status of start stop flag will be 0, then your program will go to the subroutine, that is check the status of start switch. But if the status of start stop flag will be 1, then your program will come to the next line, and here we will write that is jump CHK stop switch, and here after this line we will assign the label, that is check start switch. So here we will write that is Control C, Control V using colon, that is if the status of start stop flag will be 0, then our program will jump to the subroutine, that is check start switch, and here it will check the status of the start switch. But if the status of start stop flag will be 1, then our program will jump to the routine, that is check stop switch, and here we will write our routine, that is check stop switch, and we will copy this label from here, and here we will write Control V using colon, and we'll check that is jump not bit stop switch. So we'll write that is jump not bit stop underscore switch comma debouncing delay routine 2, that is DBD underscore R2. But if the status of the stop switch will be 1, then our program will come to the next line, and here we will write that is move DBREG2 comma hash 00H, and after executing this instruction our program will get returned from the subroutine. So here we will write that is jump SW underscore R underscore EXT, and if the status of the stop switch will be 0, then our program will jump to the subroutine, that is debouncing delay routine 2, and here we will write the debouncing delay routine 2, that is DBD underscore R2 using colon decrement jump not 0 DB underscore REG2 comma switch routine exit SW underscore R underscore EXT. But if the value of the debouncing delay register 2 will be 0, then our program will come to the next line, and here we will write that is clear the status of start stop flag. So we will write that is clear SS underscore FLG, and after executing this instruction our program will get returned from the subroutine. So here we will write that is jump SW underscore R underscore EXT, and now we will write the routine for the reset switch. So here we will write that is RST underscore R using colon, and here we will write that is jump not bit SSFLG comma RST underscore R1, and if the status of the SS flag will be 1, then our program will come to the next line, and here we will write that is jump switch routine exit. It means that if the status of the start stop flag will be 0, then the reset switch will initialize all 3 registers as unit digit, 10 digit and 100 digit to the value that is 00H, and if the counter will be in run mode, then the reset switch will not be able to reset the counter. So here we will write the routine, that is RST R1, and here we will write that is RST underscore R1 using colon, and here we will use the third debouncing delay register. So we will write that is decrement jump not 0 DBREG3 comma switch routine exit. But if the value of the debouncing delay register 3 will be 0, then our program will come to the next line, and here it will move the value that is 00H to all 3 digits, that is unit digit, 10 digit and 100 digit, and here we will write that is move UNIDIG comma hash 00H and move TENDIG comma hash 00H and move HUN underscore DIG comma hash 00H, and after moving the value 00H to all these three registers, our program will get exit from this subroutine. So here we will write that is switch routine exit using colon, and here we will write that is return. Here we have completed the routine for the switches. Let's check the working of the switch routine. As we have cleared the status of start stop flag in initialization routine, so when our program will come to this line, it will check the status of start stop flag and it will find the status of the start stop flag will be 0. So the program will jump to the subroutine that is check start switch, and our program will come to this label that is check start switch, and here it will check the status of the start switch. If the start switch will be pressed, then our program will jump to the routine that is DBD R1, and here we have the routine that is DBD R1. But if the start switch is not pressed, then our program will come to the next line, and here it will move the value that is 00H to debouncing delay register 1, and after executing this line, our program will come to the next line and will get exit from this subroutine. But if the switch will be pressed, then our program will come to the routine that is DBD R1, and first it will decrement the debouncing delay register 1, and if the value of the debouncing delay register will not be equals to 0, then our program will jump to the label that is switch routine exit, and from here it will get returned from the subroutine. But if the value of the debouncing delay register 1 will be 0, then our program will come to the next line and it will set the status of the start stop flag and it will jump to the label that is switch routine exit. It means that after debouncing delay, we have set the status of the start stop flag, and if the status of the start stop flag will be 1, then our program will come to the next line, and here it will come to the subroutine that is check stop switch, and here it will check the status of the stop switch. If the status of the stop switch will be 0, that is the stop switch will be pressed, and here it will come to the DBDR2 and it will decrement the value of the debouncing delay register 2, and it will check if the debouncing delay register 2 will not be equals to 0, then your program will jump to the label that is switch routine exit, and here it will get exit from the subroutine. But if the value of the debouncing delay register 2 will be 0, then your program will come to the next line and it will clear the status of the start stop flag and will jump to the switch routine exit. And here we have two logical mistakes in our program. That is, we have not defined the condition that when to jump to the subroutine, that is reset R. So here, after clearing the status of the start stop flag, we will remove this line from our program. After clearing the status of the start stop flag, our program will come to the routine that is reset R. And the second logical mistake is that we are not checking the status of the reset switch. So instead of checking the status of the start stop flag here, we will check the status of the reset switch here. That is jump not bit reset switch. That is jump not bit reset switch RSTR1, and here on this line our program will check if the reset switch is pressed or not. If the reset switch will be pressed, then our program will jump to the label that is RSTR1. Otherwise, our program will come to the next line and it will get exit from the subroutine. And here in reset routine 1, we have written that decrement jump not 0, debouncing delay register 3, switch routine exit. But if the value of the debouncing delay register 3 will be 0, then our program will come to the next line and it will move the value that is 00H to the unit digit, 10 digit and 100 digit. And after moving the value that is 00 to the all three registers, our program will get returned from the subroutine. And here on this line, if the value of the debouncing delay register 3 will be 0, then our program will come to the next line and here we will reinitialize the debouncing delay register 3. So we will write that is move DBREG3 comma hash 00H, and here on this line that is jump switch routine exit, we will replace this label from the reset routine R. So here we will write that is RSTR. It means that if the status of the start stop flag will be 0, then our program will jump to the label that is check start switch, and here our program will come to this label that is check start switch and will check if the start switch is pressed or not. If the start switch will be pressed, then our program will jump to the label that is dbdr1. But if the start switch will not be pressed, then our program will come to the next line, and after moving the value that is 00h to the debouncing delay register 1, it will jump to the reset routine, and here it will check the status of the reset switch. That is, if the reset switch will be pressed, then the program will jump to the label that is rstr1, and after debouncing delay, our program will move the value that is 00h to debouncing delay register 3, and here we'll replace the 3, and we'll move the value 00h to unit digit, 10 digit and 100 digit, and will get returned from the subroutine. As we have not used these flags, that is start flag, stop flag and reset flag in our program, so we'll remove these flags from the flag assignment list. And here we'll assign the address 00h to the start stop flag. So here we'll write that is 00h, and we will also remove these 3 flags from the initialization routine. And now we'll condition the timer 0 interrupt service routine with the flag that is start stop flag. So here we will write that is jump not bit SSFLG, comma T0 ISR exit, it means that if the status of the start stop flag will be 0, then our program will jump to the label that is T0 ISR exit, and it will complement the port 1.0, and it will set the status of the TR0 bit to run the timer once again, and it will get returned from the interrupt service routine, that is timer 0 interrupt service routine. But if the status of the start stop flag will be 1, then our program will come to the next line and will execute all the instructions as we have written to increment the counter with a delay of 1 second. And now we'll compile our program and we'll check the result of our program on Proteus. There is no error, no warnings. And now we will run the simulation. And here we can find the value of the counter is 0. And now we'll press the switch 1. It means that there is some logical mistake in our program, or the delay of the debouncing register is too long. So let's see how we can check the delay of the debouncing register. For this, we will go to the debug and we'll go to the watch window, and here we will add the address of the debouncing delay registers, and here we can check the address of the debouncing delay register 1 is 3AH, address of debouncing delay register 2 is 3BH, and address of debouncing delay register 3 is 3CH. And now we'll use these 3 registers to debug our program, and here we'll add the address, that is right click, add item by address, and here we'll write that is 0x003A, add, done, and here we can find the value of 3 register is 00, and if we'll press the switch, that is switch 1, and here we can find the debouncing delay register 1 is decrementing with a very slow speed, and if the value of this debouncing delay register will be 0, then the counter will start counting with a delay of 1 second. And here we can check the counter is incrementing with a delay of 1 second. And now we'll decrement the time for the debouncing delay registers. Here we have initialized all 3 debouncing registers to 00H, and now we'll initialize these registers to the 5, so that these registers will take 5 steps to reach 00H. And here we will write that is 05, 05, and we will also initialize these debouncing registers in switch routine, and here we will write that is 05H, and now we'll compile our program once again, and now we'll run the simulation once again. And here we can find the value of the first debouncing register is 5, and now we'll add 2 more registers here, that is 0x003B, okay, add, zero x003C, okay, add, and here we can find the value of all 3 debouncing delay registers, that is 05, 05 and 05, and now we'll press the switch 1, that is start switch, and here we can find the counter is incrementing with a delay of 1 second. And now we'll press the switch 2. Counter is stopped. And now we'll press the switch 3, that is reset switch. And here we can find the value of the counter is 00 now. So in this session we have learned that how to integrate the switches with our program, and we have integrated 3 switches with our program, that is a start switch, a stop switch and reset switch. And now in next session we will learn that how to use serial communication using MCS 51 family, and we will use a built-in UART of 8089C51 microcontroller to send and receive the data from the microcontroller to the real world. Thanks for watching this semi-language programming course. We hope that you find this course very helpful to learn semi-language programming. If you feel that this course contributes and enhances your embedded system design knowledge, then go ahead and hit like, share and subscribe buttons, and do not forget to press bell icon to stay updated with every new upcoming video from Electroeducators as soon as it goes up. Electroeducators also offers technical consultancy in following fields. For assistance regarding technical problems, projects and any consultancy, feel free to reach out at our email address electroeducators@gmail.com. Okay, see you in next lecture.